Hello students, let me check if sound is getting recorded. Yep. So, welcome to this video. In this video, we will solve question number 61 to 70, and the link to download the PDF will be in description, as well as at the end I will show you my website from where you can download the PDFs and maintain updated copies. I will also show you my question answer website where you can come and ask questions and give answers. So without further ado, let's get started. Now, the first matter of this video is question number 54. I have not modified it. The solution is not modified, same as yesterday. So, what happened in this question is that this number 10 is wrong. This should be 14. Okay. And in my haste yesterday, I did not look at the full solution. So, this should be 14. Once we know that this is 14, as you can see, it is written properly here. So you do column 1 is equal to column 1 plus column 2 plus column 3, and then you perform R1 is equal to R1 minus R3. So this x plus 10 and 5, and this x plus 10 and 5, this cancel each other. So you get double zeros, then you expand along minus x minus 1, and you get x plus 1 times x square plus 12x, which gives you three values for x, 0, minus 1, and minus 12. So the only mistake was over here in addition, right? It's a simple problem like that. Now we will move on to question 61. So, okay, so we'll go till question 70. Now question 61 is simple. It says we have to prove without expanding is that ABC, XYZ, YZ, ZX, XY is equal to AX, BY, CZ, X square, Y square, Z square, 1, 1, 1. So fairly standard, similar to question number 60. So what we do is we multiply column 1 by X, column 2 by Y, and column 3 by Z, and corresponding division has been made. So it becomes X, BY, CZ, X square, Y square, Z square, XY, Z, YZX, ZXY. So we take XYZ, YZX, and ZXY common from this, and we get XYZ outside. So this will cancel out each other and will become 1. And then we have X, BY, CZ, X square, Y square, Z square, 1, 1, 1 in the determinant, which is right hand side. Now question 62 says that we have to prove that ABC, XYZ, PQR is equal to YBQ, XAP, ZCR, XYZ, PQR, ABC. So this third form and first form, you can see that it is a row change of two rows. So first row is changed with third first. Sorry, first row is changed with third. Yeah. So third row is correct. And then another change is made with R1 and R2. So first and third is done. So we do the other one. That is from first to second. So what we do is we do R1 is exchanged with R2. So we get XYZ, ABC, PQR. And then you do column 1's exchange with column 2. So you get YXZ, BSC, QPR. Okay. And then you change corresponding rows into column, you get XYZ, PQR, ABC. Okay. Question 63 says that we have to find the value of the determinant. This F should be capital. We have to find the value of the determinant m factorial, m plus 1 factorial, m plus 2 factorial, m plus 1 factorial, m plus 2 factorial, and so on. And then we have to prove that delta by m factorial cube minus 4 is divisible by m. So what we do here is we take out m factorial from first row, m plus 1 factorial from second, and m plus 2 from third. Or you can take common from corresponding columns as well, doesn't matter. So we have taken out actually from columns. Okay, so these three become 1, and this becomes m plus 1, m plus 2, m plus 3. And then we have m plus 1 times m plus 2, m plus 2 times m plus 3, m plus 3 times m plus 4. Now what we do is we do column 3 minus column 2. Okay, from this we have subtracted column 2. So we get third column as m plus 1 whole square, m plus 2 whole square, m plus 3 whole square. And once we have that, the result is from the earlier 1, 1, 1, A, B, C, A square, B square, C square, and so on. We have the result as m factorial, m plus 1 factorial, m plus 2 factorial times minus 1 into 2. Once we have that, we know that delta upon m cube is equal to 2m cube plus 8m square plus 10m plus 4. And so you see this is divisible by minus 4 is divisible. Okay, so minus 4 is subtracted, it is divisible by m. Question 64 is we have to solve a system of equations using Cramer's rule. The system of equation is x plus y is equal to 4, x minus 3y is equal to 9. So our delta is equal to 1, 1 for xy and then 2 minus 3, that is minus 5 upon evaluation. And delta 1 is, that is, we ignore the coefficient of y and take the coefficient of x. Oh, sorry, delta 1 we ignore x, we take y. Okay, that becomes 4, 9, 1 minus 0, that is minus 21, and delta 2 similarly is 1. So from Cramer's rule, x is equal to delta 1 upon delta, that is 21 upon 5, and y is equal to delta 2 upon delta, that is minus 1 upon 5. Question 65 is again Cramer's rule, 2x minus y plus 3z is equal to 9, x plus y plus z is equal to 6, x minus y plus z is equal to 2. So our delta is 2 minus 1, 3, 1, 1, 1, 1 minus 1, 1. So we simply expand it. We get minus 2, delta 1 similarly we have minus 2, and delta 2 is minus 4, and delta 3 is minus 6. So from Cramer's rule we get x is equal to 1, y is equal to 2, z is equal to 3. Question 66 is we have to find the nature of solution of the equations 2x plus 3y is equal to 6, 4x plus 6y is equal to 10. So here delta is equal to 0 and delta 1 is not equal to 0. So given system of equations is inconsistent and has no solution. Question 67 asks us to prove that the system of equation is consistent. The system of equations is x plus y minus z is equal to 1, 2x plus 3x plus, sorry, this should be y, I guess, 3y plus z is equal to 4, 4x plus 3y plus z is equal to 16. So this is question number 67. All right, so we find out delta is not equal to 0. Since the delta is not equal to 0, the given system of equations is consistent and has unique solution. Question 68 says that determine the nature of solution of the equation x plus y is equal to 2, 2x plus 2y is equal to 4. So here delta will become 0, delta 1 is 0, delta 2 is also 0. So given system of equations is consistent and have infinite number of solutions. Question 69 is another system of equations questions. 2x plus 3y, 2x plus y is equal to 13, 6x plus 3y is equal to 18, x minus y is equal to minus 3. So we evaluate delta is not equal to 0, thus we have case of inconsistent solutions. I think there is something wrong here. Let me quickly see the Cramer's rule. Okay, give me a moment. So our nature was if delta is equal to 0, if delta is not equal to 0, unique solution will be obtained and system of equations will have a unique solution when delta is not equal to 0, right? So we were doing question number 68. So delta is not equal to 0, then it is consistent. So where was that? Yep. So here this is wrong. This delta is not equal to 0, this should be consistent. Okay. Now we come to question 70. We have case of non-trivial solution x plus y minus 6z is equal to 0, 3x minus y minus 2x is equal to 0, x minus y plus 2x is equal to 0. So we evaluate this is, we find it is 0, then you should also evaluate delta 1, delta 2, and you will find that it has non-trivial solution. So with this, we come to the end of question 70. I think in some of these cases, we need to evaluate delta 1, delta 2 as well. For example, particularly where delta is equal to 0, right? If you look at the famous rule and nature of solutions. So when delta is not equal to 0, it is quite obvious that it is unique solution. But when delta is equal to 0, we have two subcases. When we have to evaluate delta 1, delta 2, delta 3, and we have to find that whether the infinite number of solutions are possible or no solution is possible. Okay. So I think some of it has shortcut, particularly when delta is equal to 0. So this one is fine. Okay. These are also fine. This one we need to evaluate delta 1, delta 2, delta 3 as well. Okay. Question number 17. So that is something you need to do. I think I missed that somehow. Okay. So with this, we come to the end of question 70. And now I'll show you my website. So you can come to astrologer.org and download Algebra, trigonometry, and coordinate from link second, third, and fourth link. And the downloaded PDF will not have date, so you can add this date in the PDF. And once in 15 or 30 days, you can come and check whether there has been update. For example, coordinate will be updated soon. I have lots of material written, so this will receive an update probably today or tomorrow. And it is also available in HTML format, so you can use a browser to read it. I would recommend using Firefox because Firefox has best MathML support. It makes use of MathML. Safari, Chrome, and Edge will also work, latest versions. Older versions may have issues, particularly Internet Explorer will not be able to render the math in this book. So update your browsers and then you should be able to read the HTML format. Okay, now for the question answer website, you can click the 8th link and come at indica.astrologer.org and you can ask and answer questions here. So the subjects are mentioned which as stats, algebra, calculus, coordinate geometry, probability, trigonometry, and if your question does not fall within these subjects, you can use the generic tag mathematics. And when you ask the question, either me or one of these persons will be able to answer your question. Okay. You can't really type math into YouTube. For example, you can't draw determinants like this, but you can do that on my website. I'll show you examples very soon. I have not just got chance to work on that because I'm working on coordinate geometry book. So with this, I will end this video here, and I hope that you have enjoyed and learned something from this video. So we will meet again tomorrow with 10 more problems on determinants. Till then, stay curious, keep learning, and most importantly, enjoy.